Hello, I'm Théo Leduc and this is MoPro Virtual Reality, a molecular visualization software in VR. This is a pre-alpha demo developed by me at the laboratory CRM². So everything you see is subject to change. There are many buttons around me and I will explain what they do today. Let's go right to the point by trying to open a molecule. First we aim with the ray at a button and we can see that the ray becomes green, meaning an interaction is available. You can click anything by using the trigger button. And when we click the Open Molecule button, we can see this widget popping up. We have several files available. Of course, we have the classic CIF file format. We also have the in-house PAR file format and the very traditional XYZ file format. Let's choose our water.par file and click OK. This water dimer is described by this file. Now I want to move around my molecule and we will do that using the joystick of our molecule. The right controller's joystick controls altitude and also it controls snap turns in the horizontal plane. Now, if I want to move around in the horizontal plane, we will need to use the joystick of the left controller. Nice, we can move around in space. Just as we saw with buttons, when I hover my molecule, the ray becomes green. If I use the trigger button, I can select atoms by aiming at them. We will see in a minute what's the point of selecting atoms. Now, if I aim at my molecule with both rays and I keep the both trigger held at the same time, we can see this lightning bolt popping up. This means we are controlling the zoom of our molecule. So, when I will put my hand apart, the molecule will zoom in. Now, conversely, if I put my hands closer together, the molecule will zoom out. This will allow us to visualize molecule of any size in MoPro Virtual Reality. Of course, if I want to move my molecule around, I will need to use the grip button under your middle finger. First you aim at your molecule, keep the trigger pressed, and then grab your molecule with the grip button. As you can see here, the molecule now follows the ray. Let's load another molecule. Now we'll use this file here, which contains a protein. So when we click OK, we need to wait a little for the loading process to complete. You can see there are tons of atoms around. This protein is a glutathione S transferase. A classic representation for proteins is the ribbon representation that we will see in a few seconds. We can access the ribbon representation by clicking the toggle ribbon button. When we click it, it builds automatically this low poly mesh that represents the secondary structure of our protein. Let's zoom out a little. You can see this process is quite smooth, and also we can see 3 axes right here that display the unit cell of our molecule. Now we can zoom in, we can zoom out. We will take a look at selection modes. First, of course, as we saw before, we can select isolated atoms by clicking them individually. We can also select complete residues. For example, if I aim at this proline, we can select all atoms in our proline. This is clearer when we hide the ribbon. We can also select complete protein chains, right here. Of course, only half of our molecule will be selected because in this asymmetric unit there are 2 polypeptidic chains. We can save our selection to use it later, and the saved selection will have a blue animated effect on it. We can restore it, and we can hide it. Now we can see a lot clearer the ribbon, and we can distinguish classic features of proteins like anti-parallel beta sheets, here in red, or alpha helices in blue. You can see it's of course a lot more clear compared to the whole atom representation we have on the other side. Okay, now I want to show you another display option in MoPro Virtual Reality. Let's open our water dimer again. Here it is. And let's enlarge it. Now I want the scale of my protein to be the same as the scale of our water dimer. So we will need to first deselect all atoms and select only atoms from the molecule with the fixed scale. Now I will click the Homogenize Molecule Scale button, and this will put our water dimer on the exact same scale of our protein. So we can toy, for example, with interactions. We can wonder if this water molecule could fit between those nitrogen atoms. Of course, it can't because there's a nitrogen bond, but you can see the point. Now, in MoPro Suite, we have access to all kinds of other files. So let's close our molecule and open another one to demonstrate this. We will use this file. This is a leucine enkephalin dimer, which is a small peptide with natural opioid properties found in the brain. At CRM², we study scalar field a lot. For example, the electron density. With this button, we can open a 3D map that I pre-computed to represent this electron density. This one. We need to wait a little for the loading process to complete once again. Okay, we have our file. Now, a way to visualize a 3D field is to draw what we call an isosurface, which is a surface in space that links points with the same value. We can draw isosurface using this tool. First, we select the map, of course, if we have several maps opened. And then we choose the contour level with this little 3D slider. Let's try to grab the 0.1 value here and click OK. We need to wait a little for MoPro Virtual Reality to compute the mesh, because this is quite an HD map. And we can see these nice blue bubbles popping out. They figure the electron density around the atoms of the molecule. We can have a second surface. Let's try to catch the 0.5 value. Clicking OK will draw a second surface. Now we put a larger value, so the new surface of electron density is closer to the atomic nuclei, but we still have this nice blue halo around our molecules. Another kind of file that is supported by MoPro Virtual Reality is critical point files. In a 3D field, there are gradient vectors defined everywhere in space. At some point in space, at the critical points, the gradient is 0. So let's open the critical point file that fits this 3D map. Here, when we click OK, we can see tiny objects appearing, tiny octahedra. They figure those critical points. Let's switch the display to be able to see them a little clearer. So we can see all covalent bonds of our molecule, and we can see also blue octahedra at the nuclear position, and black octahedra at the middle of all covalent bonds. Covalent bonds are displayed by the red animated lines. There's a critical point in the middle of each covalent bond, because the electron density makes a little valley between the nuclei, and the lowest point of this valley is the black critical point. Also, non-covalent interactions have what we call these bond paths. They are displayed here in green, and there are also critical points for non-covalent interactions. The critical points file are generated by other software from MoPro Suite, but this is quite another topic. Let's switch to the classic balls and stick representation and find another way to display our gradient, because we are not limited to critical points. What we can do is to spawn a clipping plane. We choose the map, click OK, and our clipping plane will be somewhere. It's here. We can grab it by the middle using the trigger button and put it inside the boundaries of our map. When I release the trigger, the field lines that cross the plane are computed by the software. We can resize the plane by aiming at the little diamond and grabbing them, so we can get a slice, any size we want. Every time I move the plane and release the trigger, the field lines are recomputed, and you can visualize them. Let's try to get a little creative and with this visualization. So we will hide the ISO surface resize our plane and move it in some of the hydrogen bonds of this dimer. For example, right here. We can see between those atoms there's a point where all field lines are fleeing from. It's called a divergence. When we display our critical points, of course there is a critical point around this place of divergence. Great! So now you know almost everything about VR interactions and file in MoPro virtual reality. To terminate the simulation, you just click the Quit MoPro VR button. I thank you for your attention. I hope you enjoyed it. This was Théo Leduc, and I will see you in the next video. Bye!